clusters, like how we are configuring all the clusters, because clusters are the main component. Once the clusters are up and running, then we can run our projects on Azure Databricks side. So today we will be discussing on Azure data cluster pricing components, how each cluster is going to get charged by Azure. So there is a small maths behind it. We can look into that. So again, they have provided us with two things. One is a pricing calculator by Microsoft, which works on Windows machines, and the another one is a pricing calculator which work on the Unix machine. We will look into, like, once the cluster is started, we know that a Databricks cluster, as Raj has already explained, it has one driver node and multiple worker nodes. So the combination of these two creates a cluster, but it's not mandatory that every time it should have a worker node. Sometimes only driver nodes can also perform the job. So the factors that are important, which decides the what should be the pricing of that cluster, these the basic factors will be like workload. What kind of workload we are going to schedule on that? Like, is it all purpose workload, jobs, SQL, or Photon? Most of the time we are using all purpose workloads. And then tier, we already discussed two types of tiers are provided: premium tier and standard tier. So in for our project we will be using premium tier. So this also influence the pricing. Then there is a VM type, which is a type of the virtual machine that we are using. Is it a general purpose virtual machine or a GPU or an optimized version? Which kind of virtual machine we are using? So Azure has a quite a big array of virtual machines which we have to choose from. And then there are the purchase plan. We can see there are two kinds of purchase plan. We already discussed this in our initial session, like pay as you go or pre-purchased. So on the pre-purchased plan, like if there is a big ongoing project, company will negotiate with the Azure, and there is a provision for some kind of a discounting as well. So these are kind of a 1 year or 3 year plans which are pre-purchased on bulk with some kind of discount applied. But for our project, for our learning purpose, and mostly pay as you go is more popular, and we will talk about this. So now, number of factors we already discussed. These are the four major factors which influence the pricing of a cluster. Now, how the pricing looks like. So there are two things. So let's say we are creating one of the cluster here. I have captured it and a screenshot. So where you can see there are three workers, and then there is a one driver node, and then we choose one runtime environment. These are all the settings that we discussed when we are creating the cluster. And here you can see this is the name of the machine, which is like DS3, and it's V2, and this is like Linux machine, the Linux virtual machine which is running. So the two things which will play here is, one is the DBU. There in this we can see 3 DBU per hour. So because you can see the three worker nodes are already there, so there will be three normalized unit. Then there is one virtual machine. The four instances of DSV2 will be running. So we will calculate it as a one virtual machine. So basically two things are, one is your how many worker nodes are working and on which virtual machine it is working. So Azure charge for both the things, like your workers and one of the Linux machines that you are running when you are running up your clusters. Because we know that in the very starting we run that when we start the Databricks services, behind the scenes the four resources get launched. So this has been related to somewhat from those sides. So, and there is a small charge for virtual networks and public IP addresses, which will also be required for running up that cluster, but this is like a very minimal kind of a charges. Most important are the virtual machine charge and the DBU, which we can see like how to calculate. So the definition of DBU is a Databricks unique normalized unit of processing powers on Databricks Lakehouse platform used for measurement and pricing purpose. So a simple calculator for the Databricks will look like this. So first of all, we have to check like what is the number of DBU. So this will be like what is our DBU will be, and the price based on workload plus per tier. We will look into the Azure website, like how they are. This will be a fixed cost based on the machine that we are selecting. We will get this out from there, and which will make our DBU cost. Second will be our driver node. Since for our project we are using driver node and the worker node, both are on the same machines, because in this cluster you can see only one machines we have used. But in the real-time scenarios, like generally there's a combination of driver node and worker node. Driver nodes are a bit of powerful machines, and worker nodes depends upon the number of kind of a workloads that we will be running. So then we will multiply it with the price of VM, and then then this will make a total cost of cluster. Your DBUs, the driver node charges, and the worker node charges, all three when combined together, it will form the cost of a cluster. So in real world Databricks project, choosing the right driver and a worker node is crucial for balancing performance, cost, and scalability. So best configuration is driver nodes should be on D4 V2. This is like moderate size VM, and worker node should be compute optimized. So it should be standard D8 V3. These are the names of the machines which is listed on Azure portal along with their DBU charges. And cluster type should be a job cluster, auto terminated, or auto scaling enabled for scalability. So the main concept here is like we need to understand that the real-time project, there should be a mix of worker node and a driver node on that cluster, depending upon the kind of workloads we are running. So general recommendation for real-time project is driver node need enough memory to handle the job planning and coordination. Don't undersize, because from the name we know that driver node is the one who's going to assign the task to the worker nodes, and on the completion of those tasks, driver node will publish the result. So it's more important involved in planning and the coordinations. On the other side, worker nodes determine the parallelism, like how many parallel threads will be keep on executing for those. The threads will keep on running for the kind of a task. Bigger the better. Choose based on workload. Auto scaling means enable it, but set minimum and maximum limit to avoid surprise cost. And then monitoring, like watch driver per CPU, job failure, scale up driver if needed. So these are 4 recommendations while using the worker and the driver nodes. Now going back to this Azure data pricing calculations. So we see that for single node cluster, we have one driver node and one virtual machine. These are the two things which are required for calculation of the cluster cost. So for our project, we are choosing one VM and one driver node. There is no worker node in this project. So it will depend on the kind of a workload, which is all purpose. Pricing tier, we are selecting premium. Virtual machine type will be DS3 V2, and purchase plan is pay as you go. So these are the 4 factors that we discussed, which will decide the cost of our all purpose cluster. So where does this 0.7 dBu per h is coming from? You can see over here, like we can see 0.75 dBu per hour. So this is coming from this machine, which is DS3 V2, which is our VM. So this VM is costing us 0.75 dBu per hour, which is listed on Azure Databricks pricing documentation. So we will look into this in further going forward. So the instance type is a standard DS3 V2. Cluster mode that we are choosing is all-purpose. Pricing tier is premium in our case. And then according to Azure Databricks, the standard DS3 V2, which is going to be used in the job compute, will charge us 0.75 dBu per hour. Now, looking into this Azure Databricks pricing calculations. So this calculations, we can look into the website of Azure, where they are saying that for all purpose compute, they will charge 0.55 dBu per hour. And if we go to this machine, DS3 V2, they are saying it is going to cost us 0.3510 per hour. So this is that VM which is playing us, and this is with the cluster, the all-purpose compute cluster that we are creating. So these are the most important 2 things which needs to be in our mind when we are creating a cluster. The kind of a VM that will be hosting that clusters. So since it's a all-purpose compute, it will use this. If we will select as SQL compute kind of a workload, then it will be 0.22. So we have to make sure like what is the workload that we will be giving to that cluster. If it is a serverless SQL, it will be 0.475. So most, if the project only comprises of SQL query, then when we will be launching up our cluster, we will select SQL compute and not all-purpose compute, because it will save some amount of cost for us. Now, looking into the calculation, so we are launching one of the cluster where we have already decided the 4 parameters, like it will be the all-purpose cluster with the premium tier, and there will be instance DS3 V2. So the cost, how it will be calculated is the number of DBU that we can see is 0.75, and the price based on work tier is 0.55. There is one driver node, and the price for that will be the VM that DS3 V2 is charging is 0.3510. There is no worker node, so we put 0 over here. And the DBU cost is 0.41 cent For launching our cluster. For virtual machine, it is 0.35 cents. So that makes total cost to 0.76 cents per hour. So here you can see one driver node which has been launched on the DS3 V2, which is our VM, and this is our cluster. So any confusion till this point? So this is one thing, this is two thing. The third thing is worker node, which is not available in our project. So we are marking worker node as 0. This is our driver node. So this is the driver node that is coming. Here it is coming, sorry. This is the driver node which is coming. And 0.75 DBU, this amount which we are putting up over here is coming from this website, which will show us like where this price is. We can go over. So if we run our cluster for 10 hours, what will be the price? Like we calculated the total cost, right? So Raj, if you want to answer that, like let's say this cluster is running for 10 hours, how much it will cost us? Based on 0.76 cent per hour.
0.76. It will be the 7.6.
Yeah, so it will be like $7.6
the thing is like,
the cost of the cluster.
will it be the $7.6 or for 10 hours we will lose some, like they are not saying like they will charge it directly in the dollars. They are saying we will charge it in DBUs. Okay, so we don't know in 10 hours how much DBUs we will lose.
No, DBU is the power, right? It's a Databricks unit. This is Databricks unit, but the value that you are seeing up here is this is the price in cent. Okay, so this price which is coming over here is a cent price. So this is in dollars. This is in dollar. This is again price in cent, which we can see it on the website. It will make us more clear about this. So let me click on this. So this is the first one, which is our machines, the list of the machines that they are using. It will take some time to open up. And then there is the other one, which is Azure Linux Virtual Machine Catalog for the pricing. So here we can see like DS3V2. Let me go to the, this is they are talking about the virtual machine. So how you have to do is like we will choose what kind of workload we are running. So we are running all purpose. Our tier is premium. The reason is UK South we are running. Our project is hosted on that side. So we are choosing UK South, and then this is the pricing that you are talking about. You can choose from Indian INR or US or whatever it is, and then you can choose on the hourly basis, like how much it will charge for each hour. This is a saving plan which this is automatically selected because we are into pay as you go plan. And then you can see up over here the list of all the charges, like standard tier prices, which are coming like for all purpose compute. We discussed they are charging 0.dbu per hour, which is part of a standard tier price, but we are choosing 0.55 because we are into premium tier. So if you look into the calculations, it's a 0.55 dbu per hour because it's a all purpose compute cluster, and we put 0.55 over here. So
if you can see that calculation there in that chart, go up a bit. Yeah, here. See what they are saying, $1 per DBU per hour. Okay.
For inactive,
but let's suppose our query is right now is very heavy, and what it is doing, it is consuming almost 3 DBUs per hour.
Okay.
So it will become like $3 per hour.
No, this is the charge of the cluster. The query will run on the cluster that we, first of all, we have to launch a cluster on our this side, Databricks side. And then we will create a notebook or any tables, or they have charge for the DLT tables as well.
Okay.
That's a separate charge. So this is the price of the cluster, because without launching cluster, you cannot run any kind of a workload, right? It is a blank screen. It's like your mobile without internet. We cannot do anything into that. So we are paying first for the cluster, and that is why, like if it's the workload is only of the SQL type, we will select SQL compute. If the all-purpose compute means, we will run Python, we will run SQL, we will run all the things. Like if there is some ML workload, we can run it on all-purpose compute. So they have marked it over here. Enabling photon will increase DBU count. So the count of DBU is going to get increased if you enable photon also. But if you are not starting the photon, like you are only running SQL queries, let them be simple query or a complex query, they will only charge us 0.55 per DBU per hour based on the premium tier prices.
Yeah.
So that is what they are talking about. Like this is 0.75 dbu per hour, which is which in which they will give us 14 GB of memory and 4 cores will be given to us. This is the kind of a Scala runtime environment that will be given to us, and this is the charge that is being charged to us. And same way, the other VM, the virtual machine that will be hosted will be Ubuntu Linux machine. The same category will be like we'll be choosing general purpose category. Now this is for the virtual machine. This is not related to our compute side. So we will be choosing DS V3 as V3 series or DS V2 series. And then we will choose the region UK South, and based on that, we will get our pricing. I have not choose hourly. So once you choose hourly, we will get the prices in the hours. So this will make the calculation. So the second calculation that you are seeing over here is for the virtual machine that we are choosing. And then it will give us this node plus this one. And the third one is the worker node, which is not in our project. So it is 0. And they are also giving us the full price. So here, if you see, like what they are doing is general purpose they have created. So this is like DS3 V2, where they will be giving us 4 CPU cores that we see, 14 gigabytes of RAM, and this is the DBU count which they have already mentioned. Like it will be 0.75. So if you look here, 0.75, this is coming from their website, which is like for hosting DS3 V2 machine with 4 CPU, 14 GB for a general purpose machine, the charges will be, the counts will be this one. And pay as you go, total price will be 0.764. When you choose pay as you go, so the price will be 0.764. So this is coming from here. So if we are simply saying, okay, launch DS3 V2 with general purpose cluster, and we want to check the price, that is also listed on their website. So it's 0.764. Now going to the cost control settings, how we can control the settings for the costing of the clusters. So basically when we are launching our any project, we will be launching these things. Like first one will be data lake storage. Then we are also launching data factory, then Databricks job cluster, and Databricks cluster pool. Cluster pool will be there to speed up launching of the cluster. And the fifth component is Databricks all-purpose cluster. So this is specific to most of the project where Databricks has been utilized. So we need all those things like data lake for hosting raw data, data factory for doing the ETL things, job clusters. When we run our ETL pipelines, the DLT pipelines, job clusters will be created, and they will be destroyed once the job got complete. Cluster pool to speed up all these clusters, like this cluster which we are creating for our pipelines, and the job clusters, to speed up them, we have the cluster pools. So there is a negligible cost for data lake storage for a smaller project, non-build done on execution of pipeline. So ADF is also non-build. Once we will execute the pipeline, ADF will be charged, and then it will be stored destroyed. Job cluster will not charge will be negligible because those are destroyed once the job is complete. So for the smaller project, it is not there. And delete the cluster pool. Cluster pool will also be deleted at the end of the lesson. We have to delete it and set auto termination to 20 minutes. So by using this cost, mostly it will come between $15 to $25 when we are finishing up some kind of a smaller project in 30 hours. So now looking at that, all-purpose cluster will be charging us 0.76 cents per hour. Cluster up and running for 20 to 30 hours, it will be charging us $15 to $25 of charges. And we can also limit it in how we can limit it, like we have to select custom management. So now this is the screen of Azure Databricks where we are selecting cost management. Once we select the cost management, we'll come to this screen where it's saying, okay, start. So we are selecting pay as you go plan. Once we select pay as you go plan, we have different options like we can see budgets, we can set up cost alert, cost analysis, we can look, and the invoices. So once we click on invoices, we will come to this screen. So these are all the invoices that they have generated based on each month they are charging. So for every month, the invoices are coming like 7.43 pounds. So these all values are coming. Whatever is paid, it will come as paid. Whatever is due, it will come as due. And then we can set up like forecasting of that cost analysis. So actual cost is 0.09, which has been charged Great Britain pounds charged for this month, and the final bill that is supposed to come is 10.27. And here we have set up an alert, like if it reach 20, just shoot out an email to us, like the clusters are going beyond 20 pounds. So for this month, it has been estimated 10.27. So then we can look into how to set up like if budget cost exceeds threshold more than 90%, we need some kind of a alerts coming from the Azure side. So these are known as the cost alerts. So then we can set up a budget. So here you can see like the name of the instance is provided, the reset period, and 20 pounds is the budget and 50 pound is the next budget that has been sent. The spend is 0.06, 0.06, and progress you can see how much is consumed over here. So similarly, in order to set up the budget detail, give your budget a unique name. So we have to give budget a name. We have to select a billing month for which we are setting up budget, then the creation date and expiration date, and the budget amount. So for this one, like we are setting up, let's say $20. So it will set up our budget. Once the budget details are being set, we have to give your budget amount threshold. So threshold, we can give $20 or $30. Let's say we are giving $30. So we will put this amount 30 in this window, in this column, and then suggest budget for the forecast. So we want to make sure that when it exceeds 30, we need to be alerted. So for that, we will create a cost alerts. And then we can talk about cluster pool and the policies in the next session. So this is all about the pricing and the cost control, cost alert settings that we discussed. Over to you, Raj.
Yeah, thank you, Kapil. Let me share my screen. Is it visible?
Yes.
Okay. Yeah. Okay, so today we are discussing about the Unity catalog. So I have taken out some notes on the Unity catalog, like what is Unity catalog and how we can see that thing in UI in Databricks actually. Okay, so from the definitions, what they are saying for the Unity catalog. So it is like used for centralized governance on the lake house. Okay, and what are the goals here? That centralized access control and auditing for all the data assets, consistent data discovery and lineage tracking, simplified security model, supports multi-workspace scenarios. Okay, these are the main key things Unity catalog will give us in the Databricks. Okay, next thing, what is the architecture? Okay, so in architecture, Unity catalog, this diagram will give the more clarification on the architecture. So Unity catalog, for forming the Unity catalog in Databricks, we need some things like Azure data storage. Okay, based on what we will create our Unity catalog. Okay, Unity catalog metastore. This is the functionality feature we have in Databricks. Okay, after that, this catalogs, the catalogs which we are seeing daily in the Databricks, these catalogs. Okay, under these catalogs, you can see the schemas. Under schemas, tables, views, like live tables, all those things. Okay, those will come here. And access control by Unity catalog. Let's discuss these two things after some time. Okay, so we'll go through the key features also. Like again, centralized governance, fine grain access control, data lineage, auditing, data discovery, multi-cloud, multi-workspace structure. Okay, so these are the key features. We'll see this in UI also. So let me give you
Add
some.
one more point. Those are fine, right? What points you added. You can add one more point in the top list, like RBAC is very much important, and also add after this, there is one more most important utility, like ensuring compliance, which is like GDPR. If you can write it down, it will be great. Like just one line after ACL and RBACs. Yeah,
Yes,
ensuring compliance.
compliance.
Yeah. So these are like GDPR policies. GDPR, in the bracket, you can put GDPR and HIPAA. HIPAA.
Double A.
Yeah. These are kind of an important policies that can also be applied using using Unity catalogs. Which is like kind of a whole projects are coming. Most of the attractive thing is like GDPR, CCPA. These are kind of a data protection rules, which are very important nowadays. Like how our customers' data will be utilized by our organizations.
Okay. Yeah. So these are the things Unity catalog is providing to us. Now I'll just explain what is Unity catalog in actual Databricks. Okay, so every time when we will go for the definition, what is Unity catalog? So they will say like centralized thing which will used for the governance, for the fine grain access related things or permissions, those related things. They will use Unity catalog. But in actual things, we have seen Unity catalog in many times in this session also. Like whatever you are seeing here right now, this catalog, this will also come under the Unity catalog. Okay, so basically, when we are using the Databricks from Microsoft Azure, like Azure Databricks, what will happen? We will get same UI like this. Okay, but here you cannot see my organization. You can see the metastore, like Hive metastore. And under Hive metastore, we have the space for storing our data assets. Okay, but what is the difference between Hive metastore and catalog? So in Hive metastores, let's suppose for this database, for this, let's suppose new DF, one of us like Kapil have the access as admin or the modifying member of this group, and now Raj needs this for the read-only permission, or maybe he also need same kind of permission on this data set. So what Unity catalog can do, if we are giving the permission to this database, we uh, we will get all the assets which are coming under this catalog, my database. This is the catalog we have. If we will give permission to this catalog, we will get all the downstream things, access to all the downstream things. Okay, but let's suppose if we are using the meta store, there we don't have this kind of feature. We don't have the centralized governance. So for each and every table, we need to give the access. Okay, so that is the advantage we have over the meta store to the catalog. Okay, so if you can see, there are these kind of points like centralized governance. So that is what we are doing here in the catalog. Like let's suppose we need to manage something. We don't need every user to see this complete database. We can change those permissions on those users, or let's suppose if we have any group on this thing, to that group we can give the specific privileges, okay, to browse or maybe to read only, to write, all those things. Okay, so basically when we will start Azure Databricks from Azure, this Microsoft Azure portal, we will create one workspace here. Okay, this is the workspace we need to create. And after creating this workspace, if we will open this Databricks UI, you will not find this catalog. Okay, you will just find the metastore, because basically they have configured the Databricks which will defaultly give us the metastore, not the catalog. So we need to set up the catalog here. So how we can set up that thing? So you have one option here. This is the free trial, but if you have that Microsoft Azure or the paid version of Databricks, then you will get one option here to do some admin level changes. Okay, I have one screenshot here. Okay, so this is the thing you will get. So once we will open that thing, it will open one another screen, one another UI, you can say, and here you need to set up those things. Okay, if we will click on the catalog, we will get one option. We need to fill all these things from the container, from the resources which we are going to use. And after creating everything, we will get one option to select the workspaces. Okay, workspace means how many Databricks we have here. Let's suppose Databricks 1, Databricks 2, Databricks 3. Those multiple options we have, we will get option to choose how many Databricks workspaces will have the access to that Unity catalog. Okay, so the point which we have defined here, that multi-cloud, multi-workspace. So how it is going to the multi-workspace? If we are using the Azure Databricks and we will define the catalog over two workspaces, we can basically govern both the workspaces on, like, let's suppose we are creating one data set here. Okay, and we want to share that data set into the another workspace. That thing is also fine. Or let's suppose uh, any conditions which are not any condition or any lineage we have in between two workspaces, that thing also we can govern using this catalog. So we need to create the catalog in those configurations where we can use it in both the workspaces. Okay, so that kind of things we can do using the Unity catalog. So basically how we will create the Unity catalog. So to complete this form, which we are seeing here in catalog, this form to create one catalog, Unity catalog, we require some of the things like ADLS Gen2 path. And how we will get this container path? So to get this container path, we first need the storage account. Okay, if you will go to the Azure Databricks, then here we have this storage browser. Here we need to create the storage account. Okay, one of these. Right now we have only two. We can create one more. We don't have the access right now because GC admins have restricted those. But let's suppose we have created one more storage account. After that, what we need to do, we need to create one blob storage. It is like ADLS Gen2. Okay, and we need to link that storage account with blob storage. And once that is done, we need to give some permissions or roles in that blob storage. Okay, once everything is done, we have one connector, Databricks Access Connector. Okay, so using this connector, we can actually connect this storage account like blob storage to the Databricks. Okay, so once everything is configured in the Microsoft Azure, we will come to this thing and we will get like requisites, whatever is required here, whatever links or the credentials we need to fill those credentials. And once the selection for the workspaces and everything is done, we are ready with this Unity catalog. Okay, so after doing everything, we will get this option in that workspace also, my organization. Okay, and basically this is the one which is coming under the Unity catalog. Okay, so demonstrate this thing, I have one diagram. See, so Metastore is the option we will get after the catalog. Here we will get Metastore. By clicking on that thing, you will get this form. Okay, so we need to create the catalog. Okay, now in Unity catalog, what all things we are getting to govern in the Databricks. So you can see service credentials, storage credentials, external locations, all these things we will get under the Unity catalog under one umbrella. Okay, in between that we have catalog also, which have furthermore hierarchy like schema, tables, views, volumes, functions, whatever we have. Okay, so this everything will come under the Unity catalog. Now in Databricks, what all things we can do using this Unity catalog? So we can share the catalog across the multiple workspaces. How I described, like, let's suppose we have 2-3 workspaces here in Databricks. We can share the data across those. Okay, very seamlessly. We don't need to get the credentials or anything and anything. Just you need to create a catalog. Let's create one catalog test. And while creating this thing, you can configure it. You will have this option, all workspace access. Okay, so if you will give this all workspace have access, you will click this thing. So whatever workspaces we have here in Azure, it will share the data across all. Okay, so once that is done, you don't need to do anything. Just go here and create any schema, any table, and it will be visible in the another workspace also. Okay, that is one thing. Then 3 name access. Okay, so once this catalog is created, we saw in our notebooks also. Like, let's suppose in yesterday's workbook, basic operations, you saw one thing. I'm calling one table by using this kind of structure, my database dot my schema dot customer. Okay, if we don't have the Unity catalog, we just have Hive Metastore, then this is not possible. We need to give the complete path, like where that data is getting stored, on which external location, or where it is getting stored. We need to give the path and then the table name or the file name, and then we can read this thing. But in Unity catalog, this 3 name structure is there. It is easy for the access. Then lineage. Okay, now from the previous 2-3 sessions, we know lineage for the DLTs. Okay, so we learn about the DLTs, how they are tracking the lineages and everything. But one more thing is here. If you go to the normal table also, you will find out the lineage. Okay, this is the lineage we have for the normal table. So the next question crossed my mind is like, what is the use of DLT if we are getting the lineage, insights, and quality in the normal table also? Okay, so that is the thing crossed my mind. So I did some research, and here is the thing why those two are getting like differentiated. So Unity catalog gives you the lineage and access control for any table, but does not handle data quality. Okay, and it is able to handle the pipeline orchestrations because DLTs are required for creating the pipelines. Like we saw it in previous one. And advanced monitoring by itself. What is advanced monitoring? This monitoring is like, if in DLT pipeline some tables are failing, some scripts are failing, any task is failing, so DLT pipeline will restart it, or it will try to recover it. Okay, so that is the thing which is provided by the DLTs. Okay, after that, automates quality. Okay, so what is automates quality? Basically, we can write the rules while creating the table. Okay, so this is the rule. Let's suppose DLT expect valid age. Let's suppose age is greater than 0 and less than 120. If we are getting the value in between this, then only this will get that record. Okay, otherwise it will show some errors like how many are failed, how many percentage are passed, that kind of thing. Okay, in DLT pipeline UI only. Okay. So these kind of things we are getting in the DLT. And here is the question, like why use DLT tables if we have the Unity catalog? Like we have the lineage quality in both. So what DLTs are giving us, they are giving us the lineage on column level. Okay, what is column level? Let's suppose in pipeline, first task is getting one more column. Okay, and that column is required in the second task. So they will orchestrate that first task and second task based on that column level lineage, and that is provided in the DLT tables, which is not in the Unity catalog tables, like normal tables we can say. Okay, there we can just get the table level lineage, like which table it depend on which other table or the scripts, that kind of thing.
So this is
So
very good feature, right, Raj?
yes, yes,
And Ria, one question, like, do you get like what is like line automatically getting healthy or not? Raj, scroll it bit up. There is like you mentioned that DLT pipelines will automatically
recover.
recover. So what does this means? If you can try giving an answer, Ria.
Maybe sometimes if the file gets corrupted or something, I think it can recover all
Mm,
the data.
correct. So this is a very nice feature, right? So this means like, let's say, if from our project point of view, I am thinking like we are doing some kind of an extraction, like we have our Azure data pipelines as well, right? And then suddenly something happens. So this means that DLT will automatically either it will go to the restore point and try to restart that extraction process again.
Yes.
That is what it means, right?
Yeah, it will restart. It will check like what all the things are failed there. If
Hmm.
something is solvable, like resolvable errors are there, it can
Hmm.
resolve those also. Like let's
That
suppose
can
the
be like
previous one is corrupted.
okay. Password
Previous,
will also be take care of that. Like, let's say someone has generally our pipelines got failed because of the pipeline, because of these passwords and other issues. That we have
no,
to
I
check, right?
don't.
Will not be
No,
able
I
to.
I don't
Yeah.
think so. They will
And
work on
and it's
passwords
like,
because those
mm.
are the sensitive things.
But if someone has added a new column in extract and it's a DLT table, then it will try to recover it automatically.
Yes, yes, automatically. Okay,
This is
we have some configurations for that one also, like what is the time, the tries, that kind of thing. So how, like it will not do that recovery for endless time.
yeah.
We
But this
should
feature is
define
very
something.
right because
Yes,
you have also highlighted this like pipeline management, auto reprocessing, and recovery alerts. And when I was also looking today, like we want to create a DLT pipelines, the first most important thing it highlighted is like healthy pipelines.
yes.
So,
It
mm,
is like production level pipelines we can create using the
or we
DLTs.
can streaming in the streaming jobs, this is very much required. Like
Yes,
pipelines whenever.
yes. By any chance, any exceptional record will come there.
Mm,
So every other pipeline will fail because one additional column for only single record. But
right.
DLTs will handle that thing because they can change that their schema.
Mm, okay.
And yeah, built-in data quality. We saw this thing like for DLTs, we can write the rules like this if we require some kind of checks on the data which we are going to load.
We can write any type of rules, right? Whatever we are writing in the data rules, we can write all those rules.
Actually,
Like,
yeah, we can write here, but I don't think those are like like the better way to write these things. We should have one parameterized notebooks or parameterized things for the rules. Let's suppose
okay,
we created one rule null check. While
correct.
using that rule, we just need to use that null check and in bracket the value, the column name, and
Yeah,
it should give the results. That kind of things we need to explore. But
and
yeah,
that
we can write that here, but those are not manageable.
But we can write null
Yes,
check and email checks and all those rules, and then we can call them n numbers of time in different tables,
yes,
the way we are
yes,
doing in Informatica.
yes. It is just like we need to write the script once and we can call it multiple times based on like functions or anything, that kind of thing we can use. But yeah, we can replicate that functionality. Mm. So, so the main confusion there was with the Unity catalog and DLTs are like this. Like if we have the Unity catalog, we have lineage, everything there, then why to use DLTs? But DLTs are the separate things. Like they are built for some another level tasks, not the simple things. Okay, for simple things, Unity catalog tables are fine, like this, whatever we are seeing here. Okay. So basically, what I want to say is like Unity catalog is not like separate UI or separate thing. It is the inbuilt functionality for the Databricks. It is integrated with Databricks very deeply.
But you
Like
are saying we have to register for that, right, Raj, in order to get this functionality Unity catalog. The
yes,
catalog that
like
is showing on left hand side, it will not come like for you, it is coming. So this catalog is Unity catalog, right?
yes, this is the Unity catalog. Without Unity catalog, we cannot do this thing. Let's suppose here I will go to the permissions, and if I want to grant some to all users, let's suppose for all users I want to grant some role, or
Right.
here we have some things, let's suppose use schema. If I grant
Correct.
this thing for all users, now my schema will also have the use schema access for all user. This table also have that access. Everything will have downstream.
Hmm. And what is the difference you are explaining in the Azure Databricks? Like there, we will get it in the form of a meta store, right? The name will be.
Yeah, when we will create the workspace newly, fresh create. Okay,
Hmm.
at that time
Hmm.
you cannot see this my organization. Okay,
We are
you will
talking about
see one
Databricks
more
or
thing here.
Azure Databricks we are talking?
Yes, Azure Databricks.
Okay.
From here, when we will create workspace, what we will see here, we will see one more option here, have meta store. Okay,
Okay.
under that same kind of structure actually, the
Hmm.
database, then schema, all those things. But to enable the Unity catalog, you will have one manage account option here. Okay,
Okay.
you need to go there. You need to click on that manage account. There you will get one more UI
Hmm. Which is
which I
shown.
shown this one. After that,
Hmm.
you need to actually, if you see this thing, those are admin related things, user
Correct.
management, cloud resources, usage, all those things are the user related, admin related things. Those we can do using the manage account functionality. And under that, you need to create one catalog. Okay, Unity catalog. It is a meta store actually.
Hmm.
This you can see the name, but it will act as a Unity catalog for us. Okay. Once we will give the like path where we will store all this data. Let's suppose we are giving some blob storage here. So from now on, whatever we will do in this catalog, that will get stored on that blob storage. Okay, and from there they have the metadata available for everything. From that metadata, they can create the lineage for each and every table. They can give this insight, like when it was run last time,
And
what how many runs are there.
is the default blob storage, right, Raj?
Yes, when we are using the free trial, while creating this free trial, they will ask one question. Do you
Hmm.
want the express setup or do you want to create with the Amazon S3 bucket? So
Okay.
if you have Amazon S3 bucket
Hmm.
available already, you can create that environment in the free trial, and then you can go to this and create this catalog. Okay, but we don't have, so we created this express setup. So right now, this default thing they have given to us, they have
Hmm.
enabled the catalog for this one, and
Okay.
yeah, that's a good thing for us. Like we will be able to use this Unity catalog right now.
Oh.
if you go if you go to the features, you can see like Hive Metastore and Unity catalog. These two
Hmm.
things are there. So right now Unity catalog is enabled. You cannot enable this Hive Metastore right now
Okay.
because they have restricted this to
Hmm.
this workspace. Okay, with that thing, we have some more points like lineage, insights, and quality. Okay, so insights is also one of the key thing in Unity catalog. Why? Because let's suppose if we have this new DF, we can see in insights like when it was run on the June 2025. Then here we will get all these things like how many users, which are coming here, which dashboard is using these tables, and all those things. Like this is one. This is like we can say one of the governance tool for this table. Okay,
Okay.
and using these insights, we can define like, yeah, we are doing the correct thing. Because sometimes, let's suppose we are in mock 2, mock 3, and we are using the old tables. That should not happen. That's why we can govern this thing from here. Okay. In lineage, you can see this upstream, and if let's suppose we'll go to the customer, here we will see the downstream. Okay, so what is the difference between upstream and downstream? Okay, so upstream is like from this table new df, this customer is taking the data, it is receiving the data from new df to customer. Got it? Like if we are in new df and it is the upstream, like new df is giving some data to customers, new df is giving this his data to this notebook. Okay, but if we come to the customers, actually customers is our output table, so it will have everything downstream, because from this pdlt create we are getting the data from something else, some other query, and we are putting this data into the customer. That's why it is downstream. Okay, it is like they are saying from this one we got the data in the customer, like not from customer to this. This is the
It
way
is
of
talking about
identifying.
the directions like
Yes,
downstream, right? Uh,
yes,
they're not talking about upstream, right?
yes, like
Mm.
downstream, and this is our input table. That's why it have only upstream. If we have
Mm.
critical things like worksheets, service, basic operations. Actually, we don't have Unity catalog only. We need to check that thing. Okay, so that is the thing. How we can check which data is giving data to which one. Okay, and basically this lineage is given by the Unity catalog by using the metadata. So now one more thing is here, that comments to the column, so they will be searchable. Okay, so now let's suppose we have two search options here. One is here and one is here. Both will act same. This is specifically for the data and this is for the complete thing. But let's suppose we will do one thing. In the new df, we will add comment.
And these comments are searchable, right? If we want to search a discount column, we can just put discount and it will show us all the columns.
Yes, yes, exactly. Let me.
But it will not automatically generate, right? In the like if we say that okay, this is a table with 10 columns, automatically generate descriptions for all of them.
No, like that we can do when we are creating new table. Let's suppose DLT table. If we are creating, we can give this description like this comment, but not for the columns. And if we want to give these comments, we need to define these comments in the structure. Like when we are creating the table, we need to define these comments.
Like now if we want to put what does gender means, so how we can put the comments, we have to write it down, is it?
Like gender,
Hmm.
person. Okay. Name, email. Okay, we did this thing. Let's search it here first. Let's suppose mail. We are searching mail. Are we getting anything? No. Gender. No. Let me search it here. Let it get some refresh. Okay. 2 comments. Gender. It is showing the column name, but let's suppose we will do mail. Yeah, it is showing this thing. If we'll search mail.
On male or female, yeah.
It
This
highlighted it.
is
Yeah, and it has given this thing. Suppose, yeah, we are going to the table directly. So it is same like the Cortex search, if you remember the billion
But
Snowflake.
this is very easy as
Yes.
compared to.
Yes, we don't need to create. Yeah, it is actually based on the metadata, but in database, if we want to search anything in database, we have this functionality, vector search. We saw this thing like if there is some spelling mistake or anything, we can still find out. This is the thing for the comments. Now the permissions, I actually explained this thing, like how we will give the permissions to that particular data sets and how they will get it in hierarchy. Like with this database only, we will get this for everything.
Selective permission, role-based access, and even you can give role-based permissions in this data. Row-based access, and we can hide some columns as well from the other departments. So if we say that this table will show sales data to only sales department, and in the same table there is marketing data also, we can hide those marketing columns.
Actually, I'm not aware of how to do that.
Column masking is there. Yeah, we can figure out like how it is working, but this is again a very nice feature. Like for the same table, two departments can see their specific data.
Yes. Okay, so that is one thing. And user or group, this is like same thing which we saw in Informatica also. Like if they want to give access to new member, they will add that member into our group, which they created for Data Factory. Same thing, I guess. We have, yeah, groups, users, service principals. So user group, yeah, we can manage.
Databricks administrator will have to manage from developers point of view. These we should have the knowledge of them, but developers do not have to do all these things like pricing of the clusters, which clusters to launch. So because in Databricks there is lots of administrative work. So in all the projects there is a separate administrator, then there is a separate developers to execute the project.
Actually, for compute, like you said, like cluster creating and those things on administrator. But I think the technical architect or the lead, they will have the most important part here because they need to get the requirement. How much do the developer need? Like for deduplication, let's suppose I'm doing the deduplication. I will say like I'm doing this parallelism on 4 cores, but those should be like high level because they need to do the fuzzy match.
High level means like if you remember our open codes project, right? We started with 2 parallel threads, then our requirement, because it was 550 codes, right? 550 records only. Then our record count increased up to 10K for the next first series. And then we increased it to 4 threads. And then it increased up to 50K. And we go up to 16 threads because up to 12 threads, it is not going down. And when we reach 16 thread, the whole system is getting down. And then we again reduced it back to 10 threads. So something similar at a time of POC, we will decide, okay, there will be definitely one driver node. Now, how many worker nodes will be required that from a POC, it can be identified.
Yes.
And
now,
the kind of workloads we are running. Mostly the project is SQL query based, then we will put SQL compute only, not the other computes. So their computes are charged like that. If it's a machine learning load, that compute is costing more Databricks units.
Yeah. Okay. This is just 10. Let me check. I'm missing anything or not. Uh, no. Okay. So these are the additional things which I got while doing the research on Databricks platform. So they have given some like some descriptions for these things: service credentials, storage credentials. Like for service credentials, which encapsulate a long-term cloud credentials that provides access to external services. Like these storage credentials, we know that we will use for databases from which we need to extract some data. Okay, if those are on premises, then service credentials. External locations, let's suppose if you want to maintain our data in the external storages, let's suppose in ADLS, then we need these external locations. Okay, and then connections. Uh, these are like connections, credentials we can use, and we can create the connections for the database and those things. Okay, there is one thing, clean room. Okay, so using this clean room, actually, we can share the data from one cloud. Let's suppose we are working on Azure Databricks, and if we want to send the data to the AWS Databricks, that thing is possible with the clean room. I'll do some research on this thing, how we can do that. But yeah, that is also possible using these clean rooms.
Okay.
Yeah. Then shares, delta sharing observer represent the read-only collection of data. Yes, it's that data provider shares with one or more recipients and providers. Yeah, so these are some additional things, like when we are creating the catalog, here we can see the credentials, connections, external location. Let's suppose external location, what we need to do. So that thing they have given. This is the overview on Unity Catalog. So Unity Catalog is basically supporting us from the backend. It is making the work very easy for us to maintain, or to, it is also helping us to automate or orchestrate the processes by checking the lineage on their own. It is helping
Yes,
in the
and the
DLT
good
pipelines.
part is that like you don't have to invest your separate money on a data governance project. So usually
Yes.
what happens, there are on all the projects, basically once ETL pipeline is built, all the things are done, then they will come up with an idea. Okay, now we have too many data quality rules, we have too many pipelines, many tables. Now we need a data governance. But what is happening here is like your project is running and your governance part is also running in parallel to that, which is very easy to maintain.
Yes. So yeah,
So
like how we are proceeding in this thing, like whenever we are going ahead, we are getting some new things. Like today we saw this thing. What is the difference between the normal table and DLT tables? Like if both are giving the same functionality, but that functionality is on a different level. It is on table level, it is on column level. So that kind of things we are learning newly with the research. Yeah. So this is all from my side on the Unity catalog.
this is very nice. So let me stop the recordings. Any questions from anyone? We, Sai, Mansi, Ria.